Thank you for joining us today for the LEEM webinar. My name is Ann Doherty and I'm the co-founder of LEEM Advising, and I'll be your moderator for today's webinar. Today we have a host of speakers here to discuss the enormous potential of a novel big data technology called LEEM, which is short for Locational Emissions Estimation Methodology. LEEM, in effect, synthesizes emission data and energy consumption data and uses it to inform all kinds of decisions and as an input into all kinds of applications for electricity users, energy managers, energy systems, utilities, and regulators. In effect, LEEM has the ability to connect energy consumption to real-time emissions impacts. I'm excited to introduce Dr. Carol Miller, who is the mastermind behind the LEEM project, supported by a huge team of engineers and researchers at Wayne State University. Professor Carol Miller is the director of the Wayne State University Water Initiative, which includes a strong focus on the water-energy interface. She received all of her degrees from BS to PhD from the University of Michigan, Ann Arbor. Go Blue! Dr. Miller is also the U.S. co-chair of the Binational Science Advisory Board and International Joint Commission. She is also a member of the board of the Water Environment Research Foundation, or WERF. Previous appointments of Dr. Miller's include chair of the Wayne State University Department of Civil and Environmental Engineering and chair of the State of Michigan Board of Licensing for Professional Engineers. She is a fellow of the Engineering Society of Detroit, and Dr. Miller is the recipient of a number of research and development grants from agencies including the National Sciences Foundation, the Corps of Engineers, the Engineering Foundation, and the EPA is currently PI on 3 projects totaling more than $1.5 million in research funding. She is the past recipient of the Engineer of the Year Award from the Michigan Society of Professional Engineers. And if you're not thoroughly impressed by her qualifications with this biography, I can say that it's been truly a pleasure to work with Carol and to learn from her, and also just to, be proximate to all of the amazing things that she's been doing through LEEM.
Thank you so much, Ann and Allison. It's really been a great pleasure working with the LEEM to develop this first ever fully public introduction to the LEEM technology. There have been so many others involved in this journey over the past 5 years, and I'd like to acknowledge at least some of them in this limited time. Foremost, I'd like to thank that first and most important sponsor of the developments that have resulted in LEEM, the Great Lakes Protection Fund out of Evanston, Illinois. In addition, our stellar advisory board, including representatives from CMS Energy, DTE, the ERP Institute at the University of Michigan, PJM ISO, MISO, ILLUME, the National Wildlife Federation, and the business school at the Wayne State University. Most importantly, pictured in the center here, our project team, comprised of multi-talented environmental engineers, power system engineers, computer scientists, graphic designers, and marketing specialists. In addition to the WSU, that is Wayne State University, faculty and students, this team includes Commonwealth Associates, EcoWorks Detroit, ILLUME, Carnegie Mellon University, and my skilled associates at Shepherd Advisors, who have helped so much in putting this webinar together. Looking forward to a great introduction here of the whole technology. Thanks again.
Jean Rodriguez is joining us today to discuss the energy opportunities with LEEM technology. Jean Rodriguez is a vice president with ICF International and offers more than 23 years of experience in utility energy efficiency businesses. Prior to joining ICF, he served as the Senior Director of Demand-Side Management Strategy for Southern California Edison, one of the largest electricity utilities in the United States. Allison Carlson is a senior managing advisor at LEEM Advising with 8 years of experience in both evaluation and regulatory roles in demand side management. Allison brings a strong understanding of and interest in issues that affect state, local, and federal energy policy. Ms. Carlson today will be talking about the implications of 111D on our industry, as well as the ways in which LEEM might be leveraged to meet those demands. We're also excited to welcome Nathaniel Brown with Siemens, who has more than 20 years of experience in the building controls and automation industry. His career path with Siemens includes technical support, engineering, project management, operations management, and now sales. Nate will be speaking with us about the ways in which he's integrated LEEM technology into building management on Wayne State's campus, as well as the opportunities for building operations and integration with this technology. Today, I will be speaking as the co-founder of LEEM Advising and a specialist in behavior change strategies and solutions for energy programs. I'll be talking about the implications and applications of LEEM technology and the information it provides in enhancing the relevance of electricity consumption to end users. Tom Catania Jr. is the executive in residence at the Herb Institute at the University of Michigan and is a retired vice president of government relations at Whirlpool Corporation. Tom will be sharing his insight on the role that LEEM might play in developing new business models and opportunities in demand-side management services. Tom is a leader in identifying and implementing solutions to public policy programs and problems, and has spent his career operating in the complex intersection of business and government, non-governmental organizations, and public policy.
Hello, everyone. This is Gene Rodriguez. I'm the Vice President of Market Development in ICF International's Energy Efficiency Division. For those of you who know me, you're probably wondering what the heck I'm doing on this webinar. After all, I'm someone who spent my entire professional career focused on tapping into the energy, environmental, and economic benefits of energy efficiency. So what the heck is a guy like me doing participating in a webinar on locational emissions estimation methodology? Well, that's a fair question. And the answer for me can be summed up in 3 words that capture a very powerful concept. Those 3 words to me are environmentally sensitive electricity. So what do I mean by environmentally sensitive electricity? Well, let me start off by peeling away some of the layers of the onion. I'm not simply referring to clean energy supply or renewable energy. That's part of it, but not the whole. And by the same token, I'm not talking simply about the planning and dispatch of clean energy. Again, part of the puzzle, but not the whole picture. Similarly, I'm not simply referring to educating, engaging, communicating with consumers and customers in a manner that allows us to control their electricity demand. But that's, again, a part of the puzzle. And continuing along on my contrarian path here, I'm not simply referring to harnessing temporal generation data and capturing locational consumption data to gain new insights into how we might make the system work better. But clearly, that's a part of it as well. And finally, on this trend, I'm not simply referring to unlocking deeper understanding into the interactive relationship between the energy supply, dispatch, and consumption cycle and real-time emissions impacts. But clearly, that must be a part of what we're talking about today. So if you, like me, are getting a little tired of hearing me list everything I'm not simply talking about in the specific onesie-twosie manner, let me tell you what I am talking about. It's all of these things and more. The promise held by this notion of environmentally sensitive electricity is that we can take a broader, more holistic view of the energy system and the environmental impact system and be much more impactful in how we manage them both. So the other speakers on this webinar about LEEM will talk to you about the business opportunities, the DSM applications, the climate policy implications, and even the customer engagement potential of this locational emissions estimation methodology. And I encourage you to pay very, very close attention to everything that each of my colleagues has to say. But before I turn this webinar over to them, I'm going to ask you to do one thing for me. No, strike that. I'm going to demand that you promise one thing to me. As you listen to them describe the tool and all that it can do, I want you to keep your eyes and ears open for the truly transformational concepts underlying the LEEM tool. For I believe these concepts can have a truly transformational impact on how we approach the energy supply, consumption, and planning spectrum, and how we deal with the emissions impacts of electricity. For as I see it, this concept underlying the LEEM tool is much, much more than simply harnessing the power of data. And so many people out there today are talking about the power of big data. No, this powerful concept that I'm talking about is really taking an approach that marries the power of that data, making it manageable and usable, and marrying it to the empowerment of the end user so that each end user, that's you, that's me, that's everyone else in their homes and business, can choose to be a virtuous participant in the energy and emissions management system. So think of that. Instead of us being in the business of lecturing and educating the consumer and then providing them with the power and the service of with certain attributes that we believe to be important, we allow them from the demand side to help to make the system cleaner, not just because they do what we want them to do, but because they can take actions and make demands upon the system that actually help us to have a cleaner and greener energy and emissions system. To my way of thinking, this is not just incredibly interesting, this is incredibly important stuff. And I hope that you will agree with me. And as you look and hear at all of the stuff that's being presented today, that you will see and seize the opportunities being presented to each of us today. And with that, I'll turn this webinar over to the next speaker.
Thanks, Gene. So as Gene was mentioning, LEEM can provide the opportunity to shift electric loads to times when emissions are lower. And all this talk of reducing emissions is particularly relevant, I think, in light of the EPA's proposed Clean Power Plan, also sometimes just referred to as 111D. So today I'm going to give a brief overview of the Clean Power Plan and also talk a little bit about some of the implications and opportunities within it. So the objective of the Clean Power Plan is to reduce carbon dioxide emissions from existing power plants by 30% by 2030. The EPA released the draft rules on this past summer, and the public comment period ended in December of this past year. The EPA received over 2 million comments on the draft rules, so there's obviously lots and lots of interest and concern over the rules. The final rules are then set to be released mid-summer of this year. The rule will set different target emission rates for each state, with the rate being the amount of CO2 emitted per megawatt hour of power produced. And the resulting percentage reduction can vary by quite a bit from state to state, from an 11% reduction in North Dakota to a 72% reduction in Washington state. So these target rates are based on assumptions made by the EPA about how much each state can reduce their emissions using 4 different carbon-reducing building blocks. So now I'll talk a little bit about each of these building blocks, which you also actually see represented on your screen in terms of estimated costs per metric ton of CO2 reduced. The first building block is improving efficiency or the heat rates of coal-fired power plants. The EPA assumes an average savings of about 6% across the coal fleet. And the second building block includes redispatching natural gas combined cycle plants to reduce power needed from coal plants, and the EPA is assuming there that existing plants could run at an average capacity factor of about 70%. The third building block involves developing more wind and solar power, and the EPA's estimates are based on mapping renewable portfolio standards across multi-state regions. And then also this building block takes in consideration existing and future nuclear power plants. And then the fourth building block is increasing demand-side energy efficiency. For this, the EPA assumed incremental growth in electric load savings of up to 1.5% per year. This also includes state energy efficiency program savings requirements that are already there. Now, as I mentioned, the EPA's target emissions reductions by state are based on these 4 different building blocks, and naturally there's lots of debate around the assumptions that were made, the ability of individual states to meet these reductions and take advantage of specific building blocks based on their own circumstances. There's a plethora of literature and analyses and articles already out there debating these different elements. So I'm not going to get into all the issues on the webinar today, as they're a bit beyond the scope. But I will just note that to accommodate the state differences in circumstances or approach, the EPA is proposing that within the state's own compliance plans, they can choose to use these different building blocks, or they can choose to come up with their own solutions. So states can propose their own carbon reducing measures so long as the same end is achieved, or they meet the same amount of reductions. So in summary, states have an opportunity to decide how they reach targeted emission reductions. They can lean on one building block more than another. They can choose a mix of them, or they can choose to do something else entirely as it fits their situation and meets the rule. While opportunity exists for states to customize their approach, it will obviously require significant planning, coordination, and lots of data. And then when implemented, close monitoring will be required of the states, potentially across states for multi-state plans, or in situations where interstate trading might be occurring. And I think this is where LEEM really fits in and can really help states to take advantage of the real-time emissions data that LEEM has to make informed decisions on their resource mix as they're building out and implementing their own clean power plans.
Thank you, Allison, for that summary. And just to plug Bill Prindle's paper again, if you haven't checked it out, I would go to ICF's website and search for that piece of work. It's an excellent paper and definitely worth taking the time to read. As states and local agencies are looking for ways to respond to the 111D ruling, LEEM really offers compelling data to inform a wide range of responses, from environmental dispatch, which I'll talk about later, to feedback related to emissions, to building management, which Nate will speak to, as well as home automation options and energy management options, which Tom will be speaking to later. But for now, let's turn it over to Carol and learn more about LEEM and the technology itself.
Thank you. I am really excited here to get a chance to talk with all of you regarding the inner guts of LEEM. So in the next few slides, I'll be going into sort of a high-level technical description of LEEM. So what is LEEM? LEEM is the Locational Emissions Estimation Methodology, and it's a big data platform powered by Commonwealth Associates that integrates information from electricity grid databases, power flow models, and algorithms that combine these all into a solution that gives us the marginal emissions at a particular location at a particular time. What you're seeing at the top of the screen here is, on the left, it's our homepage for our industrial-facing version of the LEEM website. This is still being further developed, but this was basically our platform for industrial clients to obtain data from the LEEM data stream. On the right-hand side, you'll see some of the pre-packaged options that we've already developed for supplying our clients data, depending upon what their interest is, whether their interest is more focused on the underlying power flow characteristics, or whether it's only marginal emissions, whether it's archived marginal emissions or day ahead. So there's a variety of pre-packaged options available. Towards the bottom of the screen, you'll notice a very skeletal flowchart that gives some idea of the inner workings of LEEM. Most importantly, you'll see here that there's a variety of power flow data that comes into the algorithms, as well as air market and emissions data that comes into the algorithm. The final output being shown there at the bottom of the flow chart is the marginal emission rate, which can be given in a variety of units, but here I'm showing it in pounds per kilowatt hour. So to further answer the question, what is LEEM? I guess I'd conclude on this slide by basically saying that LEEM is an enabler of environmentally sensitive electricity. And you'll notice that on the lower left-hand side of this slide. This is really our vision, ESE, environmentally sensitive electricity. An important question is, who can use LEEM? What part of the country does it cover? And actually, LEEM can be accessed from anywhere in the world currently, but the actual geographic coverage of the data that we provide is as shown here in the slide in front of you, very much the north and the eastern part of the US. In fact, LEEM currently provides data for users in 18 states, from New York to North Dakota, whose electric grid is managed by the three ISOs that we've been working with, MISO, PJM, and New York ISO. We are striving now to find partners to enable us to expand to California, Texas, New England, and even to areas that are not managed by ISOs. So keep in mind that we're actively looking for partners that can help extend this LEEM platform to other ISOs and even non-ISO territories. And for those of you within MISO and PJM as well as New York ISO, we're ready to work with you already. Some of you may be aware that there are a variety of methods to estimate locational marginal emissions. Other methods make use of averaged emissions throughout a region, whether that be an entire ISO region or whether that be at a state or a city level. In our particular methodology, we get down to a very fine discretization, both in time and in space, to give much more accurate estimates of marginal emission on a much finer grid. At the top of the screen here, you'll see the three main building blocks of the LEEM methodology. In general, once the user's location and the time of query is known, the locational marginal price associated with the commercial pricing node nearest to the user can be identified. With the locational marginal price in our series of algorithms, we then can determine the marginal generating unit type. This provides information on a variety of things, including fuel type, heat rate, generation type. All of these allow us then to plug into additional algorithms that provide information on real-time marginal emissions. The reason that it's so important to generate this information as a function of time and space is that marginal emissions vary rapidly in time and very much are geographically dependent. At the bottom of the screen, you'll just see a MISO map replicated here showing locational marginal prices at two different times that are apart by only 10 minutes. And you can just tell by looking at the variation in colors within this very short time span that there has been a lot of change in the energy transmission features and marginal generators that are online within these regions. This is the type of information that the LEEM methodology is able to capture. LEEM provides real-time, archived, and forecasted location-specific emissions data. For a given location, data can be fed into a system that's part of a device, an energy management program, a website, or any other type of app that will then provide marginal emission, marginal generator type, and marginal locational pricing, along with other details, on a real-time, archived, or day-ahead basis. In fact, the day-ahead feature enables planning opportunities for flexible electricity usage that can be synced with times when emission profiles are cleaner. Data can be presented in different ways for different audiences, adapting to their specific needs. On this slide, I'm showing 3 different output types. On the left side, you can see a screen from the Hero Android app. Hero stands for Home Emissions Readout. As you'll notice there's features regarding a certain pollutant, in this case the user-specified lead, and the readout is providing information on current and future predicted marginal emissions at that particular location specific to lead. On the upper part of the screen is a bar of information that provides for all of the 5 pollutants timed information starting at the real time. In this case, the start time is 6 a.m. and that's the current time when this particular user gets a daily email sent to them from our Hero website. Any of you in the audience could subscribe to this Hero website and get a daily email posting of marginal emissions. So here you'll notice that for each of the icons, there's 5, let's say 5 pie slices, each one corresponding to one of the emissions that is tracked by LEEM. You'll notice that the signal changes throughout the day. So at 6 a.m., the user can determine if they would like to schedule their electricity usage according to this particular scheme. On the lower part of the screen is shown output from the LEEMco website, which is providing archived data for a particular node within MISO. Again, the user could go to LEEMco and select a particular commercial pricing node for which they are interested in archived information regarding LMP or other power flow features. And here we're seeing the data provided for a 3-day time period, 3 days in April. The current version of LEEM that's fully accessible to our customers and clients is LEEM 2.5. We're currently updating LEEM to version 3.0, and the emissions algorithms and inputs are being significantly improved to increase marginal generator type accuracy and more functionality. Improvements include probabilistic formulations of prime mover and fuel type combinations, dynamic fuel pricing, prime mover generator data, and full power flow data capture. In addition, you can see on this screen some other features that we will be adding into LEEM 3.0. All of these are ones that have been requested by those of you that we may have talked to that are already listening to this webinar, and others that we've come across. Certainly, we're expanding the geography. We're looking currently to include California, ERCOT, and New England ISOs, as well as some non-ISO regions. We're looking to add new signals showing when renewable energy is on the grid, and in fact when the electricity coming to the particular client or consumer's home is renewable energy. Also information about peak power events. We're looking to add additional environmental impacts and characteristics such as water consumption and particulates. And one that's especially of interest to a wide variety of our potential customers is the ability to count and track emissions savings. LEEM enables energy managers and devices to make better decisions. Electricity users can reduce emissions by shifting use to when the marginal generator has less emission impacts. Utilities can track load-driven marginal emissions at the local level, improve customer engagement, improve performance of energy efficiency efforts, and signal when high peak power events are likely. Providers of energy management systems such as thermostats, smart appliances, and electric car chargers can help customers optimize for emissions as well as performance and cost. Regulators can easily model and account for load-driven electricity-related emissions in real time, as well as archiving those electricity-related emissions. I'm happy to now pass the baton to Nathaniel Brown of Siemens. It's especially appropriate that Nate plays a role in this webinar, as Siemens is piloting the integration of the LEEM signal into the building energy management system at Wayne State University. It's all yours, Nate.
Thank you, Carol. My job is to encourage building managers to use Siemens building automation technologies to improve building performance and reduce costs. For example, we use smart meters and controls that can optimize heating and air conditioning systems based on real-time performance data and building loads. What my group is excited about with our work with Dr. Miller and the LEEM team is that LEEM enables our customers to now optimize energy usage in ways that directly reduce emissions. Managing also to emission is increasingly important to many of our customers, especially those that want to improve their public relations or those with sustainability goals. We like LEEM because it enables our energy management system to provide customers with the option to reduce emissions without additional cost or compromising building performance. The information from the LEEM system can easily be integrated into the building automation systems via application program interface objects. Once the two systems are integrated, a building manager could easily make a decision or plan the best sequence of operations for its mechanical systems based on the cleanest emission profile. That is the ideal situation for Siemens, is to be able to provide our customers both energy efficiency as well as help our customer achieve sustainability goals.
Thanks for that, Nate. As some of you know, LEEM is in the business of enhancing the relevance of energy efficiency and other forms of energy management like demand response in order to create sustainable and long-term behavior change. And we support our clients in doing this through a number of techniques, including upfront program design and planning support, as well as impact evaluation for their trickier and sort of new and emerging program models. And one of the things that really excites our team about the LEEM technology is that it inherently enhances the relevance of energy and electricity use to end users. As Jean pointed out earlier, and as Tom will really elaborate following, LEEM offers end users the information necessary to make different demands of their energy supply. It, in effect, raises the bar on how we think about energy and how we manage our energy, and it requires that our utilities and our policymakers think about supply differently based on that demand. Now, when we think about LEEM and the opportunities surrounding LEEM's data, one of the first things that came to mind for me was the opportunity to leverage LEEM's technology and LEEM's data in what will inevitably be a carbon market in the United States. Now, whether or not that's a result of the EPA ruling or if this is something we're talking about a few years out, LEEM offers the opportunity for environmental and greenhouse gas-based dispatch. It provides both forecasting and real-time information and feedback that, as Nate pointed out, can support building operations and management of industrial processes in a way that is sensitive to the environment, that is sensitive to greenhouse gases, to heavy metal pollutants, and other air quality concerns in a way that, we have never thought about our electricity. So instead of just thinking about constraint, we can think about responsible environmental management. And more importantly, for those of you on the phone, it creates the opportunity for building a commodity and a class of assets that can be leveraged to create and better our environmental impact, but also our energy services professions and the whole field in which we work. Similarly, when we think about the opportunity of taking this LEEM data and integrating it into feedback technologies, we inherently empower end users to manage their electricity based on the emissions that matter most to them. And you imagine moving away from this question of price and cost sensitivities around electricity and thinking instead about things that are more intrinsic motivators of people's actions and people's desires to change their behavior, like their interest in maintaining the health of their family, the well-being of their community, the environmental integrity of their cities, of their environment, of the earth in general. These things motivate and compel people. So when you think about new and emerging behavioral programs like competitions and games, imagine how powerful it would be to target, say, a densely populated urban area with communications around air pollutants and heavy metals like lead and mercury, and engaging them in challenges that manage their electricity, or engaging them in challenges to manage their electricity around these particular emissions. Similarly, you could engage in national challenges, let's say, on managing electricity demand to support the reduction of greenhouse gas emissions. You can see using feedback technologies on different devices, like, say, a Nest thermostat or an in-home display, or maybe even a home energy report, to get customers to think about the reduction of their consumption as it relates specifically to different emissions of importance to them. Now, Tom Catania is going to take it from here. As I mentioned, I'm very excited about this LEEM technology and the opportunities that it offers. And I really do hope that all of you on the phone are listening very carefully and thinking about ways that you might be able to integrate this technology into your services, into your offerings, to really enhance the relevance of electricity consumption to end users, and in the process, really improving the environmental impact that we are all having.
Thank you, Anne. I really appreciate the opportunity to talk a little bit about my perspective on this lean technology. And I have been on the advisory board for the LEEM project and have sort of focused or tried to help the team focus on market opportunities and how some of the key players in the market, especially those facing the consumer, might be interested in this technology. The first thing I want to do, though, is congratulate the entire team whose cross-sectoral collaborative process, I think, has brought this technology to its, if not ready, near ready for prime time status. I also sit on the Analysis Technical Review Panel for the National Renewable Energy Laboratory. And I think energy consumer-facing information strategies like LEEM can play an important role in facilitating bringing ever higher percentages of renewable energy onto the system. I also think that during my experience as head of public policy and government relations at the Whirlpool Corporation, I've learned that we can expect that residential consumers of home appliances are going to understand and use this sort of information. And interestingly enough, I think companies will want it themselves. On the slide that I have present there, you'll see the picture of a large building with a gigantic solar array on it. That actually represents a warehouse of the Whirlpool Corporation in Southern California. And beginning in about 2011, in partnership with Southern California Edison, that 40-acre rooftop now contains a solar array that's serving hundreds, I believe maybe thousands of homes in the Southern California area. So companies like Whirlpool were increasingly interested because they believed their consumers were interested in facilitating lowering the environmental footprint of generation. And in fact, in a recent announcement, Whirlpool has agreed with another corporation in the Ohio area to facilitate the startup of a major wind farm, and will be building dishwashers having 22% of the energy coming from wind turbines. So even for the corporation itself, as a user of energy, it's interested in where its generation source is coming from and its environmental footprint at any given time. I did spend a lot of time on the whole issue of demand response capable, or what are sometimes referred to as either smart appliances or connected appliances. And these products represent significant potential to exploit the LEEM technology by giving consumers set it and forget it kinds of options to have their products choose to engage in various energy consuming activities at times that are where the generation source of their preference is going to be most available. And for instance, activities like defrosting a refrigerator that happen once a day for a consumer, really the consumer is not very concerned about when those activities happen as long as they don't find frost in their refrigerator. So combining a smart product with a smart grid can significantly increase the likelihood that a consumer will have the ability to select the kind of generation that they prefer for certain activities of the product. Another product with a similar kind of application would be something like a smart dishwasher, where the dishwasher is loaded in the evening, and as long as the dishes are done in the morning, the consumer is happy. So to the extent that either a smart grid can communicate directly with the product, and if the consumer has selected a preference for renewable generation, wait until the home is given a signal that that kind of generation is available, or even just because they want to save money, and the LEEM data will facilitate their ability to choose the lowest cost generation mix at any time for the actual washing of the dishes. So these are just a few examples of the tremendous potential of this consumer-facing and industry-facing technology. Thank you for inviting me to participate in this webinar.
Thank you for allowing us to share with you about LEEM and some of the exciting applications LEEM is designed to enable. Please contact us if you have marginal emissions applications you'd like to explore. We have the tool, and you all have the necessary applications. We'd love to talk with you. Here, you have the chance to get in on the ground floor of this emerging and enabling technology. Again, thank you for allowing us to share with you, and the LEEM team says thank you.